This video is a continuation on the first video on basic calculus, which was on the introduction of limits. Let's have a quick recap on what we did last time. We talked about the nature of the limits. So if you could remember, limits are more concerned of the behavior of the function as x approaches to a certain value. We also talked about how to find the limits of a function by constructing a table of values or by graphing. We also mentioned about one-sided limits or one-side limits. So in order for us to find the limit of a function, we have to find the individual sides. So as x approaches, so let me give you an example for that so that you remember. So if we have the limit of a function 1 over x as x approaches 0, it means then that we have to find first the left side limit and the right side limit. So we say, what is the limit of 1 over x as x approaches 0 from the left? So meaning we only take values that are lesser than 0. And then you also find the right side limit, which is what is the limit of x as x approaches 0 from the right? Meaning we only take values that are greater than 0. All right, so in this example, we are going to use the graph of function and the table of values to determine if the limit exists for the limit of 1 over x as x approaches 0. So first here we have, this is the left side limit because as you can see, I'm approaching 0 from the left, meaning values that are lesser than 0, but getting closer and closer to 0. As you can see, I started from -7. And in this case, I ended at -1. And these are the values because remember, in order for me to find these values for f of x, I simply evaluate -7 in 1 over x, -6 in the same function, and so on and so forth. I can even extend the values, getting closer and closer to 0 because remember that the bigger the denominator here, the smaller the value. And smaller the value, the closer it is to 0 in this case. So I'm going to go ahead and show to you the graph. So this should be familiar to you because this was already discussed to you during your general mathematics encounter when you were talking about rational functions. So again, what we would want to know is that how does the function behave as it goes closer and closer to 0, which is this case, right? Now the 0 here is x. Remember that the x values are the ones that are horizontal values. So here's the 0 here. So what happens as the value of x approaches 0 from the left, meaning I'm making values closer and closer to 0 from this direction here. As you can see, I started with -7, -6, and so on and so forth. So if we go ahead and trace that, you can see that there's a certain behavior to that to the function. It goes lower and lower, right? Because as you make the values of x closer to 0, the values of y actually becomes smaller and smaller as well in the context of negative numbers, right? So it goes -4. So if you could just imagine if I would have an x value of -1 over 100, and therefore the y value or f of x value would be -100. So that would become a little further from y is equal to 0. Okay, so it becomes smaller as a negative number. The question is, as I go closer and closer to 0, what happens to the value of y? Does it mean that it would touch the y-axis? Now remember in your discussion for in general mathematics for rational functions, the y-axis here happens to be the vertical asymptote of the function y 1 over x, which means that the function would just continually go to that direction without even touching the y value. Now, what does that imply about the behavior of the function? So the behavior of the function becomes smaller and smaller. It decreases and it decreases, right? So remember, direction going downward is decreasing, upward is increasing. Direction going to the left is decreasing, and right increasing. In this case, because the function, as we move from left to right, going from -infinity to 0, the function is going from 0 seemingly going to negative infinity. So what does that imply for the limit of the function? As x approaches 0 from the left, it means that the function is actually going closer and closer to negative infinity. So remember that if we evaluate the function at 0, so if we say, like, for example, we have f of x is equal to 1 over x, and we say, what is f of 0? What's the value of the function at 0? We will get 1 over 0, and remember that's undefined, right? So if we have undefined values, it is almost always a vertical asymptote in this case, so which is here. That's the vertical asymptote there. So the limit of 1 over x as x approaches 0 from the left is negative infinity. Again, we look at the behavior of the function. But the other side. So what is the limit of function as x approaches 0 from the right? So meaning we are only going to take values that are bigger than 0, meaning positive numbers, right? All positive numbers are to the right of 0. Now, as you can see here, the values of y here are kind of identical to that of the previous table that we had, but they are just negative values. Here, these are all positive values. And as you can see, what we're doing with the values for x is that we're going from positive infinity, going closer and closer to 0, which makes sense because we're decreasing the values of x, going closer and closer to 0, but we're not going to reach at 0, right? We're only approaching 0. Now what happens to the values of x? The values of x actually becomes bigger and bigger because 1 over 7 is lesser than 1 over 6, 1 over 6 is lesser than 1 over 5, and so on and so forth. As you can see, the values of the function f of x becomes bigger and bigger, which is actually seen here in the function. As we move the values of x to 0, what happens to the function? It goes up, it goes that direction. Same question as a while ago. What happens if we go extremely close to 0 for the value of x? Like, for example, we have 0.0000001. What would happen for the f of x? On the f of x, would that mean that the function would intersect with the with the y-axis? The answer is no, because remember, it is an asymptote. So we'll only get 1, 0, 0, 0, 1, 2, 3, 4, 5, 6. I think that's correct. Yes, so basically what happens is that as the value of x goes closer and closer to 0 from the right, what happens to the function? The function goes or grows infinitely, or it increases infinitely. So we say that the limit of 1 over x as x approaches 0 from the right is positive infinity. Now remember that these two here, this one and this one, are actually just part of the two-sided limit. So this is a two-sided limit. How did we know it's a two-sided limit? Because there's no direction here above, okay? So this, the initial given was actually a two-sided limit, and we were able to find already the one-sided limits. Now, as you can see, the one-sided limits actually behave differently. As we move 0 closer and closer to 0 from the left, the value of the function goes to negative infinity. It goes down. As we move the values of x closer and closer to 0 from the right, the value of the function goes up. It increases without bound. Now, what would that imply for the limit? Say that the limit of 1 over x as x approaches to 0 does not exist because they do not share the same behavior as they go from as they approach 0 from left to right. Now, just for you to know, because it might be different in different books or different references, when we say that f of x increases without bound as x approaches to a, that's basically what happened a while ago. So when we say the limit of 1 over x as x approaches 0 from the right, we know it increases without bound. So we say that 1 over x increases without bound as x approaches 0 from the right. I'm going to say that again. The function here, so it says, I'm going to read this first. f of x increases without bound as x approaches a. The a here is the value to which the value of x is approaching to, right? So in this case, in our given a while ago, in the right-hand limit, we say that the 1 over x, or the function 1 over x, increases without bound as x approaches 0 from the right. So when we say increases without bound, it goes positive infinity. On the other hand, we say that the function decreases without bound as x approaches to a whenever it goes to negative infinity, or the function goes down without bound. So we say that the limit of 1 over x as x approaches 0 from the left, that's negative infinity. So we say that the function 1 over x decreases without bound as x approaches 0 from the left. All right, so using the graph of a function or table of values, determine if the limit exists. So I have 3 examples prepared for you guys, so you get to understand if there is a pattern on how this works. So as for now though, we're gonna just use the value of 0 as the value of a, right? So this is the value that we're going to go closer and closer to, because the functions that I'm gonna provide to you are actually resembles one another. So as you can see here, the first example that I have for you is the limit of 1 over x squared as x approaches to 0. Now this one here is kind of the same to that of the first example. It's just that we have a square in the denominator. So what I'm gonna do here first though is that I'm not gonna show to you the graph. If you would want to see how the graph looks like, you can always pull up GeoGebra and graph the function. In this case, I'm going to show to you the table of values so that you can see how the values grow or decrease. So let's first identify the left-hand limit and the right-hand limit. I'm going to go and start with the left. So as you can see here, the values of x are to the left of 0, meaning they are all lesser than 0. So if I have a 0 here, negative 10 is here, negative 1 is here, and so on and so forth. Okay, so I hope you get an idea there. So the values that I assume for the values of x, the values that I assume for x are all numbers that are to the left of 0. Okay, so as you can see here though, the values of the function f of x becomes big values, bigger and bigger, and positive. Why are they positive? Because I have a square in the denominator. So a negative value squared would always yield a positive value. So what would that imply about the limit of the function? So let's go ahead and write it down. So the limit of 1 over x squared as x approaches 0 from the left would be positive infinity. So we say that the limit of 1 over x squared increases without bound, or we say that the function 1 over x squared increases without bound as x approaches 0 from the left. Let's go ahead and do the right side of the equation here. I'm sorry, right-hand limit. So the values that I have are, again, similar to that of the left-hand limit. It's just that they're all positive. So if you could recall the Cartesian plane, or like the number line, so this is 0, this is 10, and this is 1, and so on and so forth. So I'm gonna go to that direction, going closer and closer to 0 from the right. So these are all positive numbers because numbers that are on the right of 0 are all positive numbers. And as you can see here, the values of the function also increases without bound. So it becomes bigger and bigger. The more zeros you add here before 1, the more zeros that you can see here after 1. And we then say that the limit of 1 over x as x approaches 0 from the right would be positive infinity. So again, I can always put a positive infinity or not. They do mean the same thing. And let's go to the next example here. So we have the limit of 5 over x cubed as x approaches to 0. So I'm going to go ahead and show to you the both of the sides already, left hand and right hand limit. So let's first focus on the left hand limit here. that the values of the functions that I have, the values of x that I have here assumed are, again, all values to the left of 0, meaning negative numbers, and I am yielding negative numbers as well for f of x because this is a cube. So -1 times -1 is +1 times -1 is still a -1. So as you can see here, it will then affect the limit of the function. So we say that the limit of 5 over x to the power of 3 as x approaches 0 from the left would be -infinity. Or we say that the function 5 over x cubed decreases without bound as x approaches -infinity. Right. So before I continue, let me go ahead and go back to this example here. Now, if the left-hand limit and the right-hand limit are both increasing without bound, what would that mean for the two-sided limit function? So we then say that this is increasing without bound as well. Okay, right. So let's go back here. So I'm gonna have values that are bigger than 0. So values to its right. So these are the values here, and for the x, and these are the values for the y. And as you can see here, there is a behavior that the function actually goes bigger and bigger without bound. So as x approaches +infinity 0 from the right, this is +infinity. Now because the left hand limit and the right hand limit are not equal to one another, what would that imply for the two-sided limit here? We then say that the limit does not exist. So the way we answer that is that we really write does not exist. So last example here, I hope you really are getting the pattern here already. So we have the limit of 7 over x to the power 4 as x approaches to 0. Again, left hand limit, right hand limit. So left hand limit here, values of x, values of y. Again, I am getting now positive values for y because I am using 4, which is an even power. So therefore, we say that the limit of 7 over x to the power 4 as x approaches 0 from the left would be +infinity. Right, so let's go ahead and solve for the right hand limit then. So I'm just gonna go ahead and see here that the values of x again are decreasing closer and closer to 0, and what happens is that the values of the function f of x goes bigger and bigger without bound. So we say that the limit of 7 over x to the power 4 as x approaches 0 from the right will be +infinity as well. And because the left hand limit and the right hand limit are equal to one another, we therefore say that this is going to +infinity or increases without bound. All right, so these are the 3 examples I would want you to do. Go ahead and use GeoGebra this time to find the limit of the functions here. All right, so as they are approaching to 0. So I'll be also posting questions that would hopefully guide you into understanding a generalization to these kinds of functions and limits, because as you can see here, the functions that I have here are all fractions, and they differ by different, the differences are spread all throughout it may be the sign or the numerator or the denominator, but still, again, it's still approaching to 0. So I'm going to give you a chance to do it on your own later so that you understand. Okay.